Welcome in. I know it's been a long VetSecConf. Hope you're having a great time. Today, we're going to dive deep into implementing detection as code, not just in terms of a program, but also some sample code with it. So those of you who are making detections, those of you that are perhaps creating net new content for your team, those in the SOC or security engineering side, we're going to focus on the automation of that, less so much on the creation of your regular expressions and your signatures. So hopefully that's what you're in for, and I hope you'll get something out of it. It's a little bit about me. I'm really much into detection engineering as a whole. So I'm a director of detection engineering at UKG. You might have seen E&Y on the original posting. And that's largely because I've focused on the consulting side for a little while. And for the saying here, the prerequisites workshop, you should be having an understanding of basic detection analysis, focusing on the understanding of what you can read in terms of code. But there are no prerequisites for this. I'm also giving you guys some sample code to go with this. So feel free to take a QR screenshot. And also I have links at the end of the presentation to kind of help you build this as well. I'm also going to give you a demonstration of how this works and which files that you can upload and essentially copy and paste in there and make modifications for yourselves. So great question. Thank you. Past E&Y, AWS, KPMG, Air Force 3C left in 08. And then I've kind of whittled myself into detection engineering over the years. So if you want to learn more about some of the stuff I do, just check out our Medium and GitHub repo as well. So what is detection engineering? We'll go into that definition in our agenda. We'll also look at the major CI/CD components. So if you've never built a CI/CD pipeline, we'll go over start to finish on that. What are the main issues and what are the key files that we have to look at for this? I'll go through our first deployment with using our detections inside such pipeline. And then we're going to go into testing. So how do you create a unit test? How do you create integration testing? What do those mean? And what is some sample code you can actually take away from this as well? And then last for you managers out there, program strategy. So I'm going to be focused on helping you understand how to implement this in a phase-in approach as you approach security engineering and the detection lifecycle as well. So what do we need to know about detection as code? It's really DevSecOps for the detection use case lifecycle. So for those of you that are already in detection engineering or a role specific to that, you might see a lifecycle similar to this. You're getting requirements, you're creating the development of that detection, and then you need to figure out how to do it testing-wise and finally implement and deprecate that over its complete lifecycle. One of the main things that I think it's not very clear in most cases is that we're focused on the development of the detections themselves, when we're not very focused on automating and scaling that up. So what do I mean by that? So we create detections, we test them manually each and every time. We're not using pipelines. We're not using all of our DevOps tools that we have available to us. So instead of that, why don't we put them into a pipeline itself? Why don't we also utilize our best practices in DevOps as a shift left approach? And this specific presentation, I'm going to be focused on testing and the implementation side. So how do you automate deployments? How do you create testing in a reasonable fashion? And I think that's the hardest part of kind of scaling up your detection as code as a whole. So this is not focused on development of your use cases, although I'll give you samples of what those look like. But after you create those signatures, what do you do if you create 10 signatures in a day, or even 20, or if you have a team that can create 30? What do you do with that, and how do you keep it consistent? And so this will help you understand and hopefully give you a pattern to actually copy and paste into your enterprise and your organization that goes with it. Yes, we'll have direct links to sample code to facilitate the copy and paste in there. Let me put this in the chat real quick. Most of my code can be found in my repos over here. And then I had a QR code earlier. If you wanted to copy and paste that into right here into the QR code, this will give you directly to the code I'm referencing at any one point. This is the top level repo. And then as we go through our sections, we're going to have a very specific code that I'll show you guys. And that's when you can QR code it. So you can kind of see me as well as see what's going on and then walk through and analyze the code with me. And let's see here. Okay, next slide. So what are CI/CD components? There are three main files that I want you to be aware of. The CI/CD runner, which is the YAML file at the very top right here. It's under a hidden folder called .github/workflows. And so you can actually have a bunch of orchestration event triggers based on that. So think of a pull request, or think of a commit, or any kind of action that you do with your repository. That's going to trigger an event that gets parsed into that YAML-based runner. And it's essentially a list of things that you wanted to do, like a build job or a test job. You also have two other files I want to bring to your attention at the bottom. Usually in the scripts folder, there's something like, I call it deploy.sh. You can actually be any scripting language that's supported, but also a build spec file as well. The build spec file is really for what did you change when you push that new code or new detection into your repo. And so those three are really your critical areas of where you're going to have your pipeline making run cases. So whether it be deployment or whether it be testing or all the above, those are the three minimum files that you need to make sure that your pipeline is actually a pipeline. A CI/CD pipeline consists of a repo. I'm using GitHub in our current example, and then you upload stuff to that repo, a commit, a push, or whatever it may be. You can use a GUI or CLI. It doesn't really matter as long as you have a working signature, at least based on your existing testing. A GitHub action in our verbiage case really means that you're having the workflows runner, that this thing at the top right here. And so that's going to be what's triggered every time you do something in the repo that you're filtering that trigger for. So next is the build phase. So that build phase in purple is usually when you're actually in the regular coding world, you're just compiling something or you're doing a localized syntax check or perhaps linting for that. And then you finally have your testing phase, which is making sure your functions work, making sure something works after deployment in some cases. And then you finally deploy it to production or one of the other ones. Yeah, exactly. So Megan Rohde actually created a book that focuses on the knowledge before this actual talk. So she and the other co-authors focus on how to create detections using your indicators, and I focus on the automation of those. What do you do to scale out after you operate that detection? And so post-deployment, you also have post-extended testing. So what do you do with integration testing and end-to-end testing when you need to actually do a post-deployment? So how can you know something is actually deployed and actually working beyond what you've done in a lab or non-prod environment? So that's the point of post-extended testing here. And everything else is usually just a folder based on how you want to create and organize your repo. I know that it's not incredibly exciting, but I assure you that once you create your own repo, it's very easy. You can actually do a lot of interesting things with it in terms of testing and breach automation response, depending on your tool sets. So based on that deployment, there's some general requirements that I want you all to be aware of. Remember that anything with detection as code, you have to have an API or some sort of CLI, so you can actually create scripts for that. You also need a non-GUI based way of creating use case development. So if you're accustomed to Splunk, you know you have SPL searches, but how do you package those together? And so we'll find out later on there's external tooling that'll help you with that. And there's no real direct API to deploy it without with creating an app. You also should use secrets management. So the first two, again, are focused on these two. If you don't have these two in red, you're not going to have detection as code. So some, I want to say QRadar and a few other type of solutions at your SIEM or before your SIEM actually don't really have APIs or any kind of way of giving you mass uploads of your detection cases. They may give you APIs for management of your tool, but they won't give you management APIs for your content. So that's important to keep in mind as you're thinking about your use cases and your toolings that qualify for detection as code in your program scope there. Next, you want secrets management. So what does secrets management mean to you and to me? It really means take keys, take API tokens, put them into a nice little repository that's encrypted and everything. And then you have to do zero trust essentially to authenticate to that, grab the token, and then bring it in at real time during your pipeline execution. That's what it really means. We'll use the ones that's built into GitHub in my demonstrations here, but you can realistically use any cloud one, such as a cloud HSM or secrets management solution, whichever your CSP may be. You also have a target reachability. So can your pipeline actually hit something such as your sensors for IPS deployments, or even if you're doing cloud to cloud, GitHub should be able to reach your CSP endpoints. And there's one last concept I want to kind of cover really is upstream versus downstream. When you're upstream of the SIEM itself, you're focused on indicators, you're focused on EDRs, Sericata signatures, perhaps IDSs, and perhaps firewall rules themselves, and some WAFs. Anything that feeds the SIEM is considered upstream. And that's a really good use case to start your detection as code kind of saga here, because not everything has to be at the SIEM level. You can actually start upstream with that because that's the one that has the most scale. You typically have one or two SIEMs, but you might have thousands of sensors, thousands of firewalls, and really huge amounts of environments to kind of worry about depending on what your issue is. On the downstream to the seam is also something that you need to keep in mind of where you're deploying your pipelines. So my thought is you also should deploy pipelines to the seam as well as upstream of the seam, depending on your tool set. Now, depending on your tool set also, if you have those APIs or not, really depends on where you're going to deploy those pipelines and how often you're going to actually make those pushes. Keep that in mind as we go forward. Feel free to scan the QR code for a CrowdStrike example as we move forward in there, and I'll walk you through some of the code. So what's in the CrowdStrike Falcon deployment EDR, IOA is what they call it, indicator of attack, custom use case. They don't create YAML signatures or YAR signatures like traditional EDRs that you can deploy, and it's not KQL or SPL. You're focused on the actual binary or process execution. One interesting fact about CrowdStrike EDR is that they don't actually work as a regular AV either. They only do a really, even with all your policy detections enabled full swing, they only process at the execution attempt. They actually don't process at writing on disk. So unless it's processed and loaded into memory or attempted to do it, it's actually not going to do detections any good at that level, which is why you need a combination of all the above. So in CrowdStrike, we have our Falcon example right here. Some of you are aware of this, such as VSS admin. So if you're post-exploit deployments, you've compromised domain controller, for instance, you're typically using VSS admin or low bins to go ahead and create a shadow. So for those of you who are not familiar with VSS admin, you're creating a shadow copy of perhaps the database of the Active Directory, so your NT-NIDS essentially, and then you're trying to export that to your attacking host via command and control and doing offline cracking from there. That's typically one of many use cases for VSS admin. And unfortunately, because it's useful for backup purposes, it's also one of many use cases for false positives and positive benigns right there. One of the most important things as you think about this and as you scroll through the code is the IOA schema JSON type. Those of you utilizing CrowdStrike in your commercial or your private side, make sure you download the latest and greatest JSON type. They have a whole API schema that's only authorized that you can grab. I have it in the QR, in the GitHub repo of an example template at the time of this writing. But that changes over time, so keep that in mind. Once you have that schema, turn it into JSON. So as you notice right here, I've got the values listed in there as well as the metadata. And there's really nothing that special about this particular signature. This is directly from one of their own vendor exported IOA. And if you need the schema, use the API to pull that. They have an SDK called Falcon Pi that will let you pull that example first because it won't let you do it in the GUI. And once you pull that example, you can kind of retrofit your scripts to fit that accordingly. The role group ID, which I want to highlight at the bottom here and use your specific tenant user ID, that has to be calculated before you push that rule in there. So there's some things that I do as some scripts in that repo to kind of help you out there, but I'm shortcutting it here for the time purposes in our demonstration here. Now, in our second portion of our script that you have to also keep in mind when we're looking at detection as code, at least from the CrowdStrike EDR use case, is that not only are you looking at their open API schema, you really need to focus on two different schemas. The schema of the open API itself that you're interacting with using Falcon Pi SDK in this case, and the schema of the use case itself. What you really should do is actually wrap that, modulate your scripts accordingly, and read the test use case, in this case, test rule import JSON, as a separate file to kind of keep yourself organized. And that way you can actually run the script separately from your use cases. You're not recreating code every single time. In this case, I'm utilizing their Python SDK. Their secrets you grab from environmental variables. So if you ever wondered how developers are using secrets management and actually doing it, they're just injecting it in something like set or export, or if you're PowerShell users, it might look something like this, for instance. That's how they're getting secrets in there. So if you're ever a pen tester or if you're ever a detection engineer, one of the most important things in secrets management after you get the clear text edition of it is to always clear your environment variables and secure your environment variables after each and every session of your push. Something that's really important to keep in mind, but often overlooked. So that's what I would do is if I was a pen tester, which I was, I just grab a bunch of developer stuff and that's all it really is, popping into the environment variable at build time and or runtime. Okay, so I'm going to go over a very specific application deployment, one that's kind of common in your developers kind of perspective, being kind of common inside those that are refactoring and not being cloud native, but you want the benefit of cloud anyway. So I have a GitHub repo with a runner, but the runner is going to be defined in Terraform. Terraform has their own cloud. So those of you who are not familiar with Terraform, Terraform is infrastructure as code. You might see it with AWS, Google, Azure, but it's so much more than that. So you can actually cheat and use your first Terraform as detection as code because someone else, some other developer somewhere down the line has to extract that API, turn it into an easy JSON-like format for you, and all you have to do is define your use case and push it to that point, as long as you have an API or some sort of token key identity. We're also going to deploy using the Terraform running to Cloudflare directly. So I'm using my personal account, and all of this is free, guys. You can actually use it up to like 500 resources that I'll show you in the demo. And so you can scan the QR code now, and so you can take a look at the code as we're walking through everything. And again, if you have questions, please feel free to ask. This is your time to take a look at what this means. Okay, so right here, let's make it a little bit bigger here. I'm using Terraform Cloud WAF demo. This is a private repo, but like I gave you the public version of it, copy and clone what you want. And I'm going through the main Terraform module, and it's always called main in there. And you can see my variables that I get called. Here's my direct use case. In this case, Cloudflare uses Wireshark display filters as its version of a use case. So if you're using Cloudflare WAF, that's how it works. Let's make this a little bit bigger. Terraform uses the Cloudflare firewall rule module. And so you go to the Terraform registry. I'm using the latest alpha edition, but you can use a stable edition. And so it has a lot of cool schemas here that you can look at. And so I use the Cloudflare firewall rule. I think this is going to be deprecated soon. Yeah, it is in 2025, but you can actually just move it over. But someone else is thinking about that for you. You don't have to look at the raw request that I'm showing you right here. Sorry, let me make it bigger. And you see that you need an API key, you need to use a curl command, or you use some sort of other REST API for like Python. And it's just kind of a pain in the rear. So Terraform is a great way to start off with cheating. You create a token inside Cloudflare. I'm using my personal account. You also have a free capability, I think up to like 3 rules or something. And I have a personal domain and a zone. Zones are just groups of domains. Create a custom token, and I use custom token here, and you give it a name, and give it as many permissions as you want at the zone level. And I'll show you in a second. Firewall services right here versus zone WAF here. So even though it says firewall management in Terraform, you want zone WAF permission. So make sure you have edit, and all zones in your case are a specific zone. So use least principle. And I'm doing it based on the zone, based on one or more domains here, but I'm going to use all zones. Because I already have that token, I'm going to export and download it. You only see it once. So download to a secure place or location. And again, look at your zone, which is tied usually to your domain. And I have xtechlab.com here. And you can see that I've got some hits, zone ID number and account ID number that have to become environment variables for your Terraform. And so in the security and WAF, that's where our rules will be. And because I don't pay for it, I don't have management rules. So it'll show up under custom rules. And we actually have 5 rules that you can input as a sample in there. So we use Terraform Cloud in this case. So you create a Terraform account up there. Let me make it bigger for you. There you go. And then I have a preordained workspace and project for you. A workspace is similar to a team level. A project's just like a repo level in their control set. And you can have different kind of control workflows. Terraform Cloud has up to 500 resources. So the reason why you use this over GitHub in some cases is that Terraform charges you based on number of resources, as opposed to using GitHub runners, which then you're charged based on per minute. And so if you have a very small footprint, this is more cost effective for you in the organization perspective. Check out my Terraform Cloudflare WAF demo here. Very unique name there. And I got variables here that I have to define inside Terraform. You have to define the variables inside as a runner. And notice that there's Cloudflare API underscore token. Use all caps as a best practice because that's how they do it. If you were to do this in GitHub, you would have to do a TF underscore prefix or TF underscore var prefix accordingly. And so I'm showing you right here the different run tasks and different hooks that you can do before you deploy, after your deploy. And if you can actually utilize CLI API or GitHub directly as your repo. And I'm just going over here some different costs and options, which make it a little bit more interesting to use than GitHub Action Runners if you're using Terraform. Again, 500 free managed resources, pretty good if you have a very small amount of use cases. And then you have here where I show you that this is where the last build looks like, and it looks kind of like just like everything else. So I'm going to trigger a manual run here, but every time you upload something to your GitHub, it has an auto trigger for you, and it'll run your Terraform apply scripts right there. I'm going to do a manual trigger run because we're going to pretend that I committed some code or committed a Terraform main.tf use case. We're calling exec labs Cloudflare deploy, apply, and then watch it run. And now it's not incredibly interesting to look at unless it's your first time, but you're really looking at the job runtime right here. And you see that you're not being billed based on number of seconds, you're billed based on resources, and I have 0 cost per month, which is kind of cool. And it tells me exactly what you'd run on Terraform if you did this as a developer separately on your own workstation. So now, one thing that's cool about Terraform Cloud is that it keeps state. This is the state JSON file here. And sometimes if you don't say you have a secret inside your environment variables, and close some of that here, you will see secrets commonly left in those .tf state files. So if those of you that are pen testers, post-exploitation, you'll have those state secrets, unfortunately, in there. And because I ran Terraform and it applied and gave me a bunch of green, here we go. I didn't specify and enable variables just in case that something went wrong. And so that's all it really is. It's not that big of a deal, but it's also an easy way for you to get started with detection as code. Sorry about that. And then you'll see the actions, the filters, what are optional, and some of your other schemes that are necessary for your detection use case, right? So you can run this separately, or you can run that through a Terraform Cloud runner, whichever makes sense for your organization to save money and help you scale out at the same time. Now let's go back to our talk about runners here. And so let's think about something else here. What if you didn't use Terraform? What if you had multiple use cases, multiple unit tests, right? You notice that we only just did a deploy. We didn't really do anything else with it other than validate that the syntax was correct. So this is what the runner looks like. This YAML file up here, right over here, is where your main branch is. So if I can filter it based on what kind of things like a push or a commit and what type of folder structure as well as extension type, I can say only do something based on a JSON or a build spec CSV. Now your build spec can be anything. It doesn't have to be a CSV. It doesn't have to be a JSON. It can be YAML. It doesn't really matter as long as you can parse stuff out. So all this really is, when you think about it as a pipeline, CI/CD is just glue code. It's just scripts everywhere else. You can do those based on pushes, but I also have a pull request in the main branch too. I don't talk about branching and trunking or anything like that because I'm focused on your basic deployments, but you can filter those up here at the very top. Now below IST, I have some secrets variables right here. And so your secrets will be called using this format, using the GitHub syntax. So basically you add it in there and you're good to go. So as long as you add in your repo, secrets management is free, whether you're private or public, and no one else, even if they clone it, will ever be able to see it in theory, as long as they don't get compromised. We'll see in the future. In the jobs section over here to your right, this is where the interesting stuff happens. One thing I want you to show you is that there's a cache mode in pip. So those of you that are really familiar with Python, you can do a pip install if you have a requirements.text. So if you do a pip freeze, for instance, and I'm just going to type it in here. So let's say you have pip freeze requirements.text. That is something you can use in tandem with Python with the virtual environment module as well. Using those together, you can actually set those requirements. And so instead of installing these requirements for your scripts to run or to test things every time, you're actually caching it into a storage area that you're built for, but it's less than having to spin this up from a code container every time using an ephemeral runner. And so you're actually saving the amount of minutes and time. So that's a great way to save money to help you justify spending some money on GitHub to begin with. And notice here, this is not anything crazy. You can have multiple script lines in here, run Python, run Bash stuff. And here I'm using a Python-based argument approach saying anything that's changed, only look at my build spec file because that's the only thing I care about for deployment or use case testing. So that means that if I change something up here in the rules section, up here, I don't really care unless the build spec file also tells me. Okay? And so that's really important when you're running on a team perspective because you're no longer reliant on accidentally pushing something when there's a minor update to like your metadata for updating TTP IDs, or if you're also looking at it from a perspective of like, I don't want to queue up a job because I don't want to test it. I just want it in the repo before I create my test. That's a great way to say only test something that's based on my build spec, so you don't clobber each other in a team perspective once you create a detection engineering program as a whole. So what is a build spec file? Again, this is something that's what's changed. What do I care about for deployment and testing itself? So the parsable format could be anything. I'm using a CSV file because it's super easy and I can iterate it over a loop of lines if I'm lazy. And so especially if you don't have an advanced support for like your language, I mean, Python is, for instance, most major languages are supported, but if you can't iterate easily using nested data elements, use a CSV file. It's super simple and just do it based on a per line basis and then cut it based on like a column or TD or something like that. And so use a parsable format for inputs of deployment scripts and unit testing at the same time. Here I show the test case at the very row 1, column 0, along with the expected output of my unit test, and as well as the test file itself. In this case, it's a PCAP file of a exploit here for 0 logon. And I talked a lot about testing concepts, and don't worry, upcoming, I have a demo of what this test looks like and what the logic is around that. And so there's 2 distinct ways of thinking about testing. Because we're adopting a DevOps approach, we're not really developers because we're not creating code that builds stuff, and we're not creating specific functions. We're creating something that's usually tested at deployment. And so unit test for us means we're looking at the payload locally per use case. So I showed you an example earlier, PCAP, Sericata. So think about all unit tests being more practical upstream of the SIEM. So think about EDRs, IPSs, WAFs, anything that feeds the SIEM is better in line for a unit test. Now, what about our use cases for SIEMs? Well, we have better ones for that called integration tests. So you'll create a payload and you'll emulate your SIEM systems. Now, most SIEMs will not have a capability of unit tests that allow you to be CLI only without a lot of work. You can't just install Splunk, or you can't just install Sumo Logic or Panther or whatever else you're using for a SIEM, Google Chronicle, super easily using app install and then script the rest of it to do immediate testing mode. It just doesn't work like that in an ephemeral runner. So you have to keep up with a deployed runner, and you have to patch that system, and it's just a real pain. Integration tests are best for SIEMs or that is downstream back to the SIEM as opposed to the upstream. To help you alleviate that, synthetic tests are something I coined the term, and it's really not the same as a developer synthetic test. A synthetic test in our world means you're using a RAG-based AI kind of pseudo cursory review. So you're using LLMs in my case. You've hopefully combined it with a RAG architecture, which means retrieval augmented generation. That means throw documentation that has BI or anything that's referencing to becoming an SME, make prompts out of it, and then reference the LLM using that predefined prompts and prepended information that it can use as a first-line reference, as opposed to potentially hallucinating or going out to the web for that. So it's a little bit more secure in that perspective, but a little bit less useful than a full unit test. And finally, our end-to-end test from a detection engineering perspective is a deployment test at any production level. So think of you utilizing a full breach adversary simulation tooling, Safe Breach, Red Canary, anything else that was test a cluster of TTPs from a threat-informed defense approach to your tests are called end-to-end tests in our world. In the developer world, that's a little bit different for us. So you don't see a great pair of matching. So unit test means to test a function, and you have something that passes and fails. It's a little bit harder for us because we have to create something that truly passes and truly fails, not just synthetic material. Integration test for them means API to API. So it's not just saying, hey, it works actually when you're deployed. And synthetic tests also in the world, this is more of a Datadog term that they actually produce, which is APM related stuff. And so synthetic tests in their world usually means A/B testing or some other testing from a user experience perspective. And the end-to-end means conventional testing for different edge cases such as fuzzing. And for the that are pen testers, your fuzzing is the example of end-to-end testing in some cases at the end of the pipeline, depending on their maturity. Okay, so we'll have a demo shortly, quickly on some of this, but unit testing inside the Splunk use case, you can still do unit testing. I'm not saying it's impossible, but it's actually really difficult because you have to do an installation here. And so because you can't use an ephemeral runner for most scenes, you have to use what's called a permanent or a fixed runner, and you have to create a VM on your own. You have to patch it and maintain it just like every other OS. And then you install the GitHub Action Runner agent that calls back. And so you call that runner that's on premise, and then you have that ready to go with your Splunk deployment. And you call it using simple bash or Python. SPL can be tested in a unit test-like format if you install Splunk. So the QR code here gives you the template or the sample I've used for Splunk-based searches. Now remember, this is not going to test you for enterprise security add-ons. This is just a basic deployment of Splunk Enterprise itself, but it gets you better than focused on synthetic level testing only. Again, you have build specs, and I have something called exponential backups. So maximum retries, how long between each retry, and how many tries should you actually do. So now the alternative to this is something called content CTL right over here. The problem with content CTL, well, there's nothing wrong with it. If you want to just simply deploy a single or a few use cases and not have to package everything up, or perhaps you don't have a Splunk Cloud, Splunk Content Control requires Splunk Cloud in some cases, and it's not AWS backed, you're not going to get the benefit of using that. You have to create an app, and then it wraps the app and pushes it into this management. This is a little bit easier because then you can actually just test it right here on the existing running instance using the same logic with that. Again, secrets are right here. And then, of course, you have, based on your source type, which is a Linux log audit, that is one type of a source type. And then you have your retries and other attempts as you log in. Now I'm using the environment variables with authentication here. Your best practice is always to use a token whenever possible, but this is just for demonstration purposes only. Here for basic validation, I'm doing something that is really the first start of your testing type logic, which is, did you receive something? Did you get the expected output and exit as a non-zero if you did not? Non-zero means, in a process execution perspective, exiting zero means system didn't have a problem. It doesn't mean that you didn't have a problem within the application not parsing something. It didn't mean that the test failed from that perspective. But this is the most basic unit test, which means something didn't error out because I found something. And so if I say within those tries, a test failure means I did not find a result of one or more log entries based on that SPL query. And so exiting of one or exiting of non-zero here is the most convenient way of showing you that I need to fail this test and give an error state message to the analyst or engineer in charge of that pipeline build. And so that'll give me my state. The past state is obviously exit zero right here. And it's basically saying, hey, wait for it to catch up in the index. Make sure you have at least one result, and let's go ahead and for it. And then you need to restart the test just in case after you've loaded some log files in there. So I've given you some of that. This is a snippet. But again, this is in your QR code in our sample that I had earlier in there. Okay, I promised another demo, and I am going to give one here. This one is Sericata. So you'll have GitHub, and I'll use the Sericata IPS as an example. That's another upstream portion of the same. And I'm going to use this time GitHub Action Runners and the repo itself to kind of combine the two. I don't have any secrets in here because we're not doing anything with the cloud or anything else with another authentication-based system, but it is something for you to utilize. And later on, at the end of this course, I also I have some other references for you, not just unit test it, but also auto deploy at scale across all of your different Sericata IDS engines, as long as you have that read and SSH access to it. Okay, so let's get started here. So I have my Sericata unit test CI demo. Let's make it larger. And I have GitHub action flows, and as well as some build spec files and all the files I talked about last time earlier in the slides. So let's go to the rules, actually tests. And then here we have the PCAP that I just showed you here. Again, you can copy these files in the code I give you and just essentially commit and clone them. Here's the rule right there. That's essentially the Sericata rule. If you click into it, and it's snort style, as you can see here. This is something I just stole from emerging threads, so don't sue me for it, but you know what the structure looks like now. And I have two different testing scripts up there just for shell commands, but I actually finalized mine in Python, so you have my mentality there. So you can see I'm just parsing a CSV file, and then Python, it's pretty trivial. And then I iterate over the rows. So this is how you would do it without using any kind of special CSV import, and then close the file handle for best practices, and then run Sericata in a read PCAP test mode only. So it's not that difficult. And here I'm showing you the config file for the Sericata itself. You have to enable logging to actually get this unit test to work. So fast logging at the minimum, but you can also enable EV JSON logging for the payload itself if you want to get crazy with it. I like to use a sleep timer to catch up to the file system every time I'm writing to disk. And then my try, pass, if else statements are right here based on if you found the name in the context. So basically, substring, grep, no case there. And that's all it really is. And then I like to clean up the files afterwards, because if you're using a long-term runner, you're eventually going to have log files, and the agent doesn't do it for you unless you clean it up in your runner. Okay, so let's go to the actions right here, clean up the tabs a bit, and then I'm going to show you the runtime of it. So having UI problems here. So essentially, this is what it looks like in just like I showed you earlier. So it's nothing special. It just runs it. And again, you can commit files and make those changes using the GUI right there. And it's the same as using the command line to push the branch right here. So same as git push and git commit am. Okay, so back to our orchestration here. I'll show you this. Again, that's how I'm filtering it. You can do it based on folders too. Workflow dispatch is something you need to keep in there if you're using my particular examples, because it allows you to go ahead and manually trigger the files themselves, manually trigger the pipeline if you're using my exact template. Okay, so let's go into the runs. And you can see I've run it to do some testing over the time, and I want to run workflow manually. Now, this doesn't become anything super special too, but notice that you'll see some, if you've never seen it before in GitHub, this is interesting to watch. And so you see it based on your charge time and usage of your compute, and you have your runtime name there or your build time name there based on your runner. That is based on your job ID in your YAML file, not the file name itself. And so you have your usage there, and you get build after your runtime here. And as you can see, it gets kind of crazy here based on your packages. So whenever you can, if you're using something beyond apt-get, if you can use pip checkout means, you can just use it, go back into the working directory here. And I'm installing Sericata. Notice that there's warnings there. So if you can possibly use a long-term runner, sometimes those are better than having an ephemeral runner in containers, but these are usually cheaper to deal with. I'm running my Python right here, and notice that I'm using verbose mode inside and I see a pass right here because I ran it and it saw it inside fast.log, and that's my printout and deletion. Yay, not the hardest thing in the world, but I wanted to make sure that you know that 31 seconds still gets rounded up by the minute to GitHub. So you get charged for the 1 minute anyways. So something to keep in mind moving forward. Okay, so some of you are here because of the synthetic example right here. So AI is how you utilize synthetic testing in there. So Python right here, you can use the POE API. It's a really interesting facet of using multiple LLMs for AI runners here. And so when you lack the resources to actually test or create unit tests, or you have complex use cases that are very difficult and very expensive to test manually, you can utilize a second pair of eyes in terms of the AI here. You grab the code right here based on the QR, and then at the very end of our presentation, I'll show you links to show you how to use multiple LLMs to vote on something, and then you can actually tally the vote on how you want to pass or fail some tests. So you have to tune these based on reducing the hallucinations. Setting the temperature below 0.5 right here is usually the case. Of lower is better in most cases. So regardless of your POE, if you're Azure, if you're OpenAPI, Cloud, or something like that, or Anthropic, whatever you may be using, lower temperatures are better, but it actually has less capability of thinking outside the box. Higher is better if you want more generative features. Lower is better if you want tried and proven features, so long as you augmented that. And here I'm just using the prompt as a preprocessor right here, and I'm kind of augmenting all of that together. And I'll show you in the demonstration how to kind of make it more RAG in a cheap and easy format for your testing purposes. And so now I generate a structured prompt, again, reading the CSV file for build spec, and then taking the log file and of my true positive right here, as well as my test case, and I'm going to create a prompt inside as well, and I'm going to issue another prompt. And we looked inside the QR code, and you're staying with me on this, is that the prompt itself acts as a precursor buffer. You append this up top, then you have your use cases and your true positive, and if you want, your false positives at the bottom, and you can ask it a very specific question. So each and every time you're asking it a very structured question, as you can see right here, in markdown-like format. And if you pin that huge context in there, depending on how long your use case is, you can actually fit your whole prompt inside a single token, or the maximum amount of tokens supported by your LLM. And then I have my thing right here as a in POE specific SDK right here. Okay, so how do you actually utilize this and turn it into something? I found that LLMs at the time of this writing, as well as this presentation, really difficult to achieve with giving you a confidence score, like a statistical score of 0.95 and a confidence interval, or just any other like 0 to 100 kind of confidence scoring on its own. So it's better at analyzing things and then giving you a qualitative score for some reason. I don't know, but that's what I found in my testing. And so you can actually use a high, medium, low, which I found pretty useful. And then an unknown for a catch else. And so if you use it, this is just using one bot, giving it high for saying, go ahead and pass the test on the cursory review. Use a warn exception instead of a pure exception. So you'll still exit 0, but you should look at your logs for there. And everything else that doesn't do that, you should exit 1. That way you kill your build job accordingly. So what are we doing here? We're going to do a quick demo of the POE using Splunk SPO without having to use Splunk for a permanent runner. And then, of course, your QR code right here for the exact one-to-one demo example that I have here. All right, so Chow AI Unit Synthetic Testing SPL. I'm very original here, but notice that I have the same exact runner information here. Pull the secrets, and this time I'm only using detection as a folder. And then you'll use a POE_API. That's POE.com/API_key, if I'm not mistaken. Anyways, go to your secrets and actions variables in your repo, in your settings, and then just add that new repo secret there. Whether it's basically foreign coded or not, doesn't matter. It'll populate it into its appropriate environment variable as a single line. And again, I'm just running that test right there after installation, not doing anything from a deployment perspective, but I have scripted examples for you for there. Again, grabbing from the environment variable, and then I'm constructing my bot override characteristics regardless of what I'm using. And I'm saying use a lower temperature. And I'm just iterating, like I said before, and concatenating all that using the logic here under the main driver. And that way I can kind of modulate what I need. And then I can actually create 2 LLMs I want. And I'll show you that link later on at the end of our course here. So POE.com allows you to have multiple LLMs. It's pretty cool. $20 a month for the subscription side. You can use it for free if you want, but I don't think you get the API key if you don't pay for it. So $20 to try it out. It's not that bad. There is a trial edition every once in a while. Claude 3 Haiku is cheaper, but you can also use Gemini and 3.5 Sonnet. And then you can have knowledge bases right there, as well as advanced stuff in here. Knowledge bases allows you to make it more RAG, so add your SPL documentation in there. And then if you want to go to your POE API, it doesn't really have a good documentation for you. And I'm going to show you what mine looks like. I've already generated, but I'll change it after this. It doesn't matter. I don't have anything crazy in there. And the fast API _POE API reference is what you'll be using if you have Python. POE.com_API. Here's what mine looks like. I'm going to regenerate it anyway, so don't worry about it. Okay. So back over here, I'm going to, where are we going to go here? We're going to go and here we go. I've got this tab open. You can actually pre-process the prompt saying in Markdown, here's your guidelines. You're a bot that does this. And so instead of chatting about it, you'll focus on getting the responses. And I upload PDF files of SPL and other details about, in my case, Sericata, but I also did about Splunk too. This takes a little while to index, and POE.com does not have this in their documentation, but you run into a 50 megabyte limit. And then once that indexes, that becomes your RAG, and then bring that down temperature-wise to like 0.15 or something. And then like this becomes your this becomes like a better like bot tune for your preferences for making sure things are right and you're less likely to hallucinate. Okay. So let's go ahead and let's run this guy. And I think, yep, actions. And then I've got my builds here and caches you can check if you want. But again, detections. And here's what my SPL looks like in case you were curious. And just, I stole this off ESCU. And they also have some cool logs in there, which I also stole, which was also Splunk, that you can find their use cases if you dig in their GitHub enough. So let's go back to actions and run this guy real quick. And sorry, I'm running out of steam here. And then here's the detection test run job here, and it's going to go call out to the API. So you have network access directly from the GitHub ephemeral runner. You might, here's the thing though, if you use multiple LLMs, you're going out to the network, you're using APIs, process exit code 1, I cannot have access to private bots, allow retry. So that's what happens when I don't have public bot enabled. This is a limitation in POE.com right now. So just keep that in mind. A public bot means that if someone finds your name and as a POE subscriber, they can actually technically use it. I'm going to fail jobs, boom. And this is the same thing if you were to do GitHub action commits and pushes. Now we see the checkouts and we get the responses back. And notice that it's not perfect. It's going high, 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 high. And so you might want to tune your markdown more because it says hi, we're passing our test and then we're cleaning up, and our build job usage is charged based on total seconds. And now I have 51 seconds charged to my account accordingly. So I'm going to turn this guy off, and you should turn this off too if you're doing the same thing, and play with it. See it's not too bad. And then turn off the publicly accessible mode and site sources mode as well for best results. And that way you don't have the API pool using up all your tokens and your thresholding for a simple demo. All right. So the last part of our item that I want to leave with you before we go is program strategies. So those of you that are managers out there, you have like 4 different levels of, similar to the CMMI chain perspective. So there is something called the detection maturity matrix that someone in SANS created back in a couple of years ago. And so, but I want to put a little bit more rendition on that. I'm focused on the maturity of detection as code. So first off, start off with your repo, create your most basic CI/CD pipeline runner. Focus on change control by itself. Next, focus on refactoring your CI/CD to include tests, such as unit tests. That's one of the easiest ones to do. That's where you can use unit level testing as opposed to downstream scene testing. Level 3 is to achieve end-to-end testing. So if you have a BAS tool or a solution, a Red Canary, a Monkey Island comes to mind, or any kind of commercialized solution, use those and you test based on TTP IDs as threat-informed defense clustering. And then level 4, use your augmented use case generation and deprecation. This is something I didn't cover in this talk, but it's important from a to-your perspective. If you're looking at it from a CISO's eyes or perspective, that this is a better use case for AI, getting those quick wins and saying, hey, I'm shifting left for detection engineers using AI to augment their test case creation, where you're only reviewing it. And so you can actually create a pipeline for intake, a pipeline for testing, and a pipeline for deployment. So you can actually have pipelines chained together if you really want to get to that level. So that was a lot. Hopefully you got some items out of it. And really, that's all I have for you right now. But detection resources that I want to give to you is detectionengineering.io, which is our matrix. Some SANS webcasts that tell you and help you kind of facilitate why you need to have detection engineering, and especially the automation of that detection engineering to your SOC environment or your engineering environment. The Google Cloud community had a nice workflow. We can try it out with Google Chronicle. If you haven't played with that scene before, it's a really nice sandbox that you don't have to set up yourself. And so you can kind of play around with the pipelines and sample ideas and their skill boost kind of thing. There's detectionengineering.net. So Zach Allen from the Datadog side runs a lot of those weekly newsletters if you're interested in keeping up with that. And then again, I promised you bonus code. These are the bonus codes that I'm going to be providing to Dave Johnson from CyberWalks that recently left Datadog to Amazon. And so I'm giving you a similar logic code to use LLMs for multiple LLMs right here. So I'm giving you the logic right there in the main driver, as well as direct Terraform usage in the GitHub runner versus using Terraform Cloud. Awesome. Tell Zach hi from me. I've only met him like once, so it's been a long time since I've seen the DD team. And then, of course, the GCP PubSub policy as code, which I didn't cover here, that you can use PubSub or kind of AWS Word SQS queuing. And you can look at the states inside those queues to actually test instead of using direct logging. So if you, for whatever reason, have ephemeral logging challenges, this is a great way to actually utilize a different way of testing and looking at state in there. So that's it from me. Did any of you have any other questions or thoughts or anything else before I adjourn here for this session? Okay. Well, if you have something later on, find me on VetSec on the Slack. Hopefully you get to see some of the other sessions because I ended a little early, hopefully. And hopefully got something out of it. Thank you for coming.